This truckload of sugarcane is about to become far more than just sugar.
We see the crystals. Inside the mill, one stalk begins splitting into entirely different worlds.
Once cane is cut, quality begins declining, so getting it processed quickly matters. And here, a harvest measured in truckloads becomes a continuous river of raw material.
From thousands of stalks, follow just one, and watch how many times its identity changes.
Before extraction, dirt and field debris must be separated from the cane entering the process. Then, rotating knives attack the hard stalks, opening them before the real crushing begins. In seconds, something that looked like solid wood becomes a loose mat of exposed fibers. Now comes the force most people never imagine when they pour sugar into coffee. Steel rollers compress the shredded cane, forcing juice out while the fiber keeps moving.
One stalk has already become two streams, and both of them still have somewhere to go.
The first squeeze isn't enough. More liquid helps recover sugar still trapped inside the fibers. After the final mill, the remaining fibrous material leaves with a new name: Bagasse. It looks like waste. And that assumption is exactly where this story becomes more interesting.
The juice is heading toward sugar, but the fiber is beginning a completely different journey. This single truckload of sugarcane is about to undergo an extraordinary physical transformation. It will become far more than just the simple table sugar we expect. From this mountain of raw plants, multiple industrial paths will soon emerge. The process is fast, violent, and highly efficient at every stage.
We are all familiar with the final product: pure, sweet crystals. But we rarely consider the colossal machinery required to create them. To understand this scale, we must look closer at the raw plant.
A single stalk contains complex layers of fiber, water, and sweet juice. The moment the cane is harvested, a critical countdown begins.
With every passing hour, the sugar content inside the stalks begins to drop.
Speed is essential. The mill must run continuously, day and night.
The massive receiving yard is designed to process thousands of tons daily.
Here, the harvest is measured not in sacks, but in endless truckloads. The material forms an endless, slow-moving river of green and gold. Speed is essential. The mill must run continuously, day and night. The raw stalks are now pushed into the heart of the refinery. Let us follow just one single stalk among millions of others.
It still retains the raw, organic characteristics of the muddy field. In moments, its physical structure will be broken down completely. The first step of this industrial transformation is thorough purification. Powerful spray nozzles wash away loose soil, sand, and field clay.
Removing these abrasives protects the heavy machinery downstream from damage.
The cleaned stalks are now ready for physical destruction. Every second counts as the raw material approaches the primary knives. A series of high-speed revolving knives waits to shred the stalks. The tough, fibrous exterior is violently sliced open in a split second.
This process opens up the plant's internal cell structures.
The cane is no longer recognizable as a plant. It is raw feedstock.
Next, the shattered pieces enter the powerful industrial shredder.
Extreme mechanical force hammers the cane into a soft, damp pulp.
It now looks like a continuous, moist carpet of raw organic material. Every sugar-rich cell is now exposed and ready for extraction. Behold the primary extraction mills, towering monuments of pure steel power.
They exert thousands of tons of continuous hydraulic force.
The damp fiber is drawn into the crushing jaws of the first mill.
The extreme compression forces the sweet, internal liquids to escape.
For the first time, raw sugarcane juice is liberated.
It flows like a small river into stainless steel collection channels below.
This cloudy, sweet liquid contains the essence of our final product. But the crushed fiber still holds a significant amount of sugar. At this exact point, the single stalk splits into two distinct paths.
The liquid stream is pumped away for clarification and boiling. Meanwhile, the fibrous carrier travels onward to the next extraction stage. To extract the remaining sweetness, a clever chemical process is introduced. This is imbibition, washing the fiber to dissolve any remaining sucrose.
The moisture penetrates deep into the pre-crushed organic material.
The wet mixture is immediately subjected to a second crushing phase. A second stream of diluted juice is successfully recovered.
This sequence repeats multiple times across a long milling train. Now, the fibers reach the final and most powerful squeeze. Having given up almost all its sugar, the fiber is now dry. The plant material has now received a brand new name, Bagasse. This byproduct is transported out of the processing building.
It cascades continuously, forming an enormous mountain in the yard. What looks like a massive mountain of waste is actually highly valuable.
This biomass will soon serve a vital, self-sustaining purpose.
The single stalk's journey has successfully diverged into two clean routes. The juice is heated and clarified, preparing to crystallize into pure sugar.
And the bagasse will be burned to generate electricity for the entire mill.
An incredible loop of engineering, where nothing is wasted and everything has purpose.
Fresh from the centrifuge, these crystals still carry moisture, and the journey isn't finished.
Controlled drying removes excess moisture so the sugar can be handled and stored more safely. After drying, the crystals are cooled before they continue towards storage.
One stalk has become millions of crystals, and now those crystals move by the ton.
Before another journey begins, samples help confirm what this batch actually contains.
At many cane mills, raw sugar is the product that leaves for a separate refinery. And that means the same sugar may enter an entirely new factory.
The golden color isn't simply deep inside every crystal. Much of it surrounds the surface. The first refining step loosens the molasses-rich film coating the raw sugar crystals. Centrifugal separation removes that loosened surface material, leaving cleaner crystals behind. And then something unexpected happens. The refinery deliberately dissolves the crystals again.
The solid sugar we waited so long to see has become liquid once more.
Now the dissolved sugar can be purified again, removing material that shouldn't reach the final crystals.
Specialized treatment removes much of the remaining color before crystallization begin again. The crystals have disappeared. To make white sugar, the refinery must create them all over again.
Before crystals can return, more water must leave the purified sugar liquor. As evaporation continues, water leaves the process, and the dissolved sugar becomes increasingly concentrated. Then the concentrated liquor enters the vacuum pan, where crystallization can begin again. The liquor is concentrated until it reaches the condition needed for sugar crystals to grow.
Crystallization begins with tiny nuclei that give dissolved sucrose somewhere to join. As the process continues, those tiny beginnings grow into a new crop of sugar crystals.
When the crystal-rich batch is ready, it leaves the pan for separation.
High-speed centrifuges separate the new crystals from the liquid surrounding them.
A controlled wash removes more of the remaining liquor while the crystals stay behind.
And there it is, the brilliant white sugar hidden inside the cane from the very beginning.
Up close, the familiar white powder is actually a moving landscape of individual crystals.
The moist crystals are dried and cooled before they can move toward final handling.
Mechanical screens can then separate the finished crystals by particle size.
Finished granulated sugar can now move into sealed packages for storage, distribution, and sale. We found the sugar. But remember the steam created from the bagasse? Its journey isn't over either. One possible destination for molasses lies beyond the sugar factory altogether.
For some facilities and markets, this sugar-rich stream becomes a feedstock for fermentation. Instead of crystallizing more sugar, the remaining sugars can now enter a biological process. The feed is prepared under controlled conditions before microorganisms begin converting its sugars. During fermentation, microorganisms convert fermentable sugars into ethanol and other products. After fermentation, separation takes over again, this time inside a distillation system. Distillation concentrates and separates ethanol from the fermented mixture. In this route, sugars that never became crystals can ultimately leave as an ethanol product. But fermentation is only one possible destination for molasses. In another supply chain, molasses can enter animal feed manufacturing instead. There, controlled amounts can be blended with other feed ingredients inside industrial mixers. The same dark byproduct can therefore leave another factory as part of an entirely different product. And we still haven't returned to the solids separated much earlier from the cane juice. After filtration, this material is commonly known as filter cake or press mud.
And in some sugar industries, this residue can return to farmland as a soil amendment or fertilizer source.
And even the fiber has another story. Burning it for energy is not its only use. In some supply chains, selected bagasse leaves the energy route to become industrial fiber raw material.
And once again, one harvest opens the door to an entirely different factory.
Up close, bagasse isn't simply debris. It is a mass of rich plant fibers. Before fiber manufacturing, the material must be prepared and unwanted fractions separated.
In a pulp route, processing prepares those fibers to form a new material.
Here, the valuable fraction is no longer sucrose. It is the fiber itself. Spread across a moving surface, loose fibers join into a continuous sheet. Mechanical pressure removes more water and binds the fiber network tightly together.
Controlled drying removes remaining moisture until the wet fiber becomes a stable sheet.
This former residue now leaves the production line as a usable sheet material.
And that material moves onward into products looking nothing like crushed cane.
Other manufacturing routes can use bagasse fiber in board products instead.
Fuel, paper, board. The same residue carries different value depending on its destination. By now, the cane is energy, materials, fertilizer, but we must still follow the sugar.
After factories, refineries, and warehouses, part of the harvest finally reaches a place everyone recognizes. For the consumer, all of that machinery has been compressed into something small enough to hold in one hand. But much of the sugar leaving refineries never goes directly to a household. In bakeries, sugar becomes part of structures, flavors, and textures that look nothing like the original crystals. Mixed into batter, the sugar disappears from sight, but not from the process. Under heat, sugar contributes to sweetness, moisture, texture, and the browning that makes baked foods so familiar. By the time it becomes dessert, almost nothing about the finished food resembles the cane field where the story began. Give those crystals direct heat, and another identity appears: caramel. The solid crystals become a liquid flavor, color, and aroma created by heat.
Then scale changes again, because beverages can use sugar by the tank rather than by the spoonful. Here, sugar can be dissolved into syrup before controlled amounts enter a beverage formulation. In preserves, sugar joins fruit in another transformation, helping create the sweetness and concentrated texture people recognize. And after all that industrial scale, the journey can end with something as ordinary as one spoonful.
That spoonful carries a story of crushing force, heat, separation, energy, materials, logistics, and far more than sugar alone. Across the food world, sugar leaves the refinery, only to disappear into thousands of other processes. Sometimes it becomes sweetness. Sometimes it becomes shine, texture, and a finished surface. In confectionery, sugar enters yet another world of heat, concentration, and controlled cooling.
Water leaves, temperature falls, and a flowing sugar mass can become something hard enough to snap.
Change the recipe and the same ingredient can help create a completely different texture. In chocolate, sugar becomes part of a complex balance between bitterness, fat, aroma, and texture.
Lower the temperature instead of raising it, and sugar enters an entirely different sensory world.
In beverage plants, speed becomes the spectacle. Thousands of servings moving through the line every hour. Once food is made, another machine takes over. Logistics.
One harvest has now fragmented into products, heading toward completely different customers.
At wholesale markets, industrial-scale production meets thousands of individual buying decisions.
After the controlled rhythm of factories, the same supply chain becomes noise, color, bargaining, and human movement. Here, industrial sugar becomes something personal again, made one serving at a time.
By the time it reaches a restaurant table, almost all traces of the original mill disappear.
You may never see the machinery, but every bite carries the work that happened far upstream.
One serving looks small until the same ingredient is multiplied across an entire evening of service. And one bakery can repeat that demand from morning until closing time.
Then multiply one shop by every cafe, restaurant, bakery, and store along a single street.
And multiply that street again across an entire city. In most of these places, no one is thinking about sugarcane anymore. Behind the storefronts, however, pallets and trucks keep rebuilding the supply chain every day. Consumption empties the shelves, while logistics fills them up again. And back upstream, warehouses are doing the same thing in reverse, shipping out while new production arrives.
When the city settles into night, processing may still be running.
Different workers take over, but the physical chain of heat, pressure, motion, and separation continues.
Even at night, another stream of crystals can still be moving toward storage. While finished sugar leaves one end of the system, another harvest is already arriving at the other. In one place, raw cane enters. Somewhere else, finished products are already leaving.
And eventually, the story leads back to where every industrial route began, a field of cane. One plant feeds food, energy, and commerce, sending its ultimate value back to the land.
Long before sugar reaches a machine, the chain begins with people working where the cane grows. Then someone has to move a heavy, time-sensitive harvest from field to factory. At the mill, another team takes over as raw agriculture becomes industrial material. Operators watch machines that must keep turning while tons of cane continue arriving.
Quality is not judged by appearance alone. Technicians measure what the eye cannot reliably see. Elsewhere, another crew keeps the mill's heat and energy systems under control.
Finished sugar still needs people and machines to turn production into dependable deliveries. Then the chain leaves the factory and enters roads, depots, and distribution networks. For another worker, the finished product becomes a raw ingredient all over again. And another transformation begins, not in a refinery, but in a kitchen.
Commerce adds another human layer: weighing, buying, selling, and choosing.
For a cafe, the same supply chain may arrive one drink at a time.
And even material removed during processing can still create work and value back on the land.
By this single spoonful, almost every part of the real journey has become completely invisible.
The most revealing part is what happens to the material we almost called waste.
On one route, bagasse becomes a fuel for the mill's heat and energy system. On another route, cane fiber can leave looking nothing like the residue that entered. The same fiber supports very different industries, depending on the supply chain built around it. Then there was the dark stream left after sugar recovery.
In one downstream industry, remaining fermentable sugars can become feedstock for fermentation.
In another supply chain, molasses can become one ingredient in manufactured animal feed.
And even the solids removed during clarification did not necessarily mark the end of the chain.
In some systems, that material can return toward agriculture as a soil amendment or fertilizer source. Fiber, molasses, filter cake, three streams that never became a spoonful of sugar, yet still carried value.
That changes how the harvest looks. It is not just one product waiting to be extracted. It is one biological material capable of splitting into several industrial possibilities.
And once those roots separate, value begins leaving the original mill through completely different doors. Different factories, different customers, different products. The same plant at the beginning.
Perhaps the question isn't how sugar is made, but how much hidden value one harvest contains.
Every industrial story began with something much quieter: land, time, and a growing plant. Then agriculture met machinery powerful enough to break the harvest apart. Heat, concentration, and separation turned what was hidden inside into something recognizable. Millions of crystals finally emerged from a plant that looked nothing like sugar. But the crystals were only one result. Other parts of the harvest carried value elsewhere. Even the fiber could become energy in one route, or useful material in another. And some of what processing removed could eventually find a useful path back toward agriculture. Between field and consumer stood people whose work remained almost invisible in the final product. Then the industrial ingredient quietly disappeared into foods, drinks, stores, and kitchens.
By the time people bought it, almost every machine behind it had vanished.
But now we have seen the hidden system behind something that once seemed completely ordinary.
So look at this spoonful one more time.
After everything behind it, the final step takes less than a second. Ordinary sugar is ordinary only when we cannot see the world that made it possible. Come with us into the hidden world, because ordinary never looks ordinary again.